Hello. In this video, I would like to go through the document that you see on your screen that is devoted to custom OpenIAM .NET and PowerShell connector development. This document describes pretty well the ways how you can start developing your own connector. However, I think it would be good to go through the same document on the video. And probably it would be even more clear. So we can start with connector architecture overview. And actually, .NET PowerShell connectors in OpenIAM are built on using classic Windows services technology. So it's based on Windows services. So when a connector is installed, you get a constantly running Windows service. You can see it right here, and it is responsible for all communication between OpenIAM and the process itself. So it actually receives requests from OpenIAM and returning responses, and it's not responsible for handling requests themselves, but it does like top-level management of everything that is happening later. So this connector service actually depending on configuration can start one or more connector request runners. So these connector request runners are independent applications that are being started by this Windows service, and they communicate using inter-process communication using net pipes. When connector service receives request and it has a connector request running, it sends information about this request to a request runner, and the request runner itself, it takes care of splitting the data of this request, because connector request contains different types of data. So the one that is most important from a business logic is like a business logic data that is that describes, for example, the information about some particular user that needs to be provisioned to some remote managed system, and it also has service data that explains how a connector should respond, the queue names, and etc. Connector request runner, it splits the data, and it refines the whole request, and keeps all information, all service information within himself. And the business logic data is being sent to external PowerShell script, which is open sourced. And this PowerShell script is responsible for implementing any business logic. So as you know, PowerShell is built on top of .NET, and it's very tightly integrated. So actually you can do anything that you need on .NET using PowerShell as well. So you can implement your custom logic on using PowerShell, pure PowerShell, or you can create your .NET libraries and call them from a PowerShell script, and if that works better for you. So in this architecture, all you need to do to create a new connector is to develop or to modify a PowerShell script. So you don't need to do anything with request runners or Windows services. You just deal with a business data, and that's all. And connector will take care about returning data back and communicating with OpenIAM. So you don't need to recompile anything. You just take a PowerShell script file and do whatever you need to do. So that's what is described in this section. So the next section is about generic connectors. So as we have just described, so um, this part, like main Windows service and connect request runner, they remain the same. So all you need actually to do is to work with a PowerShell script. So generic connector is the same build of a connector as different types of connectors, but instead of some implementation that is particular for some managed system, so it has just placeholders for different functions that needs to be implemented by a connector to be able to do what every connector from OpenIAM perspective should do. So actually, a generic connector is like a connector template. And if we go below, go next through this document, we will see that there is a chapter that is called working in a simulation mode. So simulation mode is the mode that gives us ability to simulate every request from OpenIAM side, but without the actual call. So we can simulate this request and work with test data. So this chapter describes the structure of the this connector file itself. So I have a generic connector installed, and it looks like this. And actually, this section describes the functions that are located inside a generic connector. So if we open this connector.ps1 file, let's open it with using Visual Studio Code, and I trust my environment. So you will see that you have several functions like save identity, remove identity, and then search data if I collapse them. So suspend identity, and so on. So the meaning of that functions are described here. So save identity is intended to create a new user, so modify if this user exists in a remote system, and the same for removing, suspending, resuming, resetting password, and testing the identity password. Of course, if this is available for your remote managed system. And function search data is intended for getting information from a remote system. For example, when OpenIAM needs to import users or objects in general from some remote system. Okay, so actually, as we describe on this picture here, the request data are sent from a request runner to a PowerShell script. So consequently, it receives some data, and some global variables are available for you when your script starts. So this section describes these global variables. It is a request string, the connector operation, request ID, and the minimum log level. So you see that we have commented 2 lines that describe the same. So actually, it says that simulation mode. Simulation mode actually it's just a simple replacing of the request string to the content of some external files. So if we imagine that our request appeared appeared in a RabbitMQ, then the main process service received it and sent to request runner. A request runner did some operations, and it sent a request itself to a PowerShell script. So the body of the business data of this request would appear inside this variable request string. So actually, instead of receiving the same data from OpenIAM, it is possible just to serialize and save the same request string to some file and then read this file later. So if, and this is described right here, that if we go to line 214, let's go 214, not here. Oh, okay, it's 222. Okay, yeah, it means that maybe we have some additional lines in this. Yeah, so it has some additional lines like testing some other functions. So it's just a test script. So you don't need to pay attention on this, but in a default file, it will be in line 214. So in our case, so there is a like variable if we are replaying a simulation, and if we set it to true, we will just read the content of the specified file in a simulation folder, and we just specify a connector operation here just because the serialized content of the file doesn't contain the operation itself. So that is why we just set the operation name here, because the structure of the file is the same, and there is no way to distinguish it using this serialized value, because the type of operation is been related to the just service data, and it is not available inside this script. So for simulation mode, we just set it ourselves. So let's imagine that we have a save operation, and also there is a simulation folder, and it is described in this document that you will have the same simulation folder that will be located in the same folder as this document, and there will be a couple of scripts that is called like save example and search example, and so here are two examples here, and we can just copy the file name and put it here. So that's everything that we need to do to run a request. So let's just open this file just to take a look what it looks like. So it contains this business logic data that was sent from OpenIAM site, and it contains attributes, and inside this attributes section we will be able to see the data that are related to a particular user itself. So let's imagine that we have a save operation, and OpenIAM requested us to create a user in some remote system, in Active Directory, maybe in Exchange, maybe in Azure, or SAP, or some other system. So this file says that the identity name will be a user principal name in our case, and identity value looks like this. So it is the main value using which connector can find the user in a remote system and do operations later. So for example, the first action that connector needs to do is to check, do we have this user with this user principal name in our remote system? If the user does not exist, it means that connector needs to create this user. And if it exists, it needs to modify this user, but not just blindly modified, but depending on the information that is sent inside the attributes here. So if we take a look, so here is a display name attribute, and the value of this attribute is like this, and each value has an operation. So in our case, operation is add. It means that we need to set a display name equal to this. And if, for example, we will have remove, not remove, sorry, delete. Delete operation, it means that we need delete this attribute itself in a remote system, or if it's not possible, just to make it clear, to set it to null, for example. So there are just several possible operations here, and they are described in the document. So it's like add, then replace, then delete, and no change. So looks like, yeah, so the meaning of them are obvious. So we can see the attributes here, and what's important is that for example, we see the attribute name groups, and the values itself, it contains not just one value, but as you see in a JSON structure, it is an array of values. So it could be one value, maybe it could be null if no data is sent, or it can contain just several values, like for example group A and group B, and the operation is independent. So we see that for this test user we have operation, we need to add this user to group A, but we need to remove this user from a group B. And also, if we scroll down, we will see that there is a section that is called metadata, and it contains data about operation, data about that is not related to this operation in particular, but to all operations in general. For example, this request was taken from Active Directory connector, and it says that, for example, we have an URL. This is a URL of a domain controller, and we have a login and a password. So when connector will work with this data, with this request, and will be trying to save this user, it will be connecting to Active Directory using this username and the password, and connecting to this domain controller. So it is possible to specify your own data that are related to all requests in general. So I hope that it's more or less clear. So, and all of is described here is how to run this operation. So actually that's all, and let's proceed to maybe more interesting sections. It's a description of some global variables that are available inside the whole script. So as you see, when we received this request, connector calls convert to header attributes, OIM attributes, and search attributes. So it just separates the values of this JSON file inside convenient global variables that you can access in the whole script. So for example, let's scroll down a little bit and see if connector operation is like save. It means that we will just call a save identity function. So let's scroll up and find it. It doesn't matter actually. So by default, let's take a look here. So when we will run this save request, our request will appear here, and let's just put a breakpoint here and execute this file. We will be able to execute this file just because we see that this parameter of replaying a simulation is set to true, and we have pointed um, to load the values, the request value from this file, so the one that we have just seen. And I would like also to make sure that I'm running a PowerShell 5.1, so it's not a PowerShell built on .NET Core, because right now OpenIAM connector using classic PowerShell, not the one that is built on top of .NET Core. So so we have a breakpoint here, and let's execute. So we see that we have successfully received our request, and we see a breakpoint here. And let's go back to a document, and let's see the global variables like header attributes. Let's we have a console here, and let's print $header attributes, and we see that it just uh, it just gave us easy access to this section with a metadata that we have just discussed, that contains like username and URL for a service account. So all values are stored here. So, for example, if you would like to get the login that we use for our service account, we can just reference it like header attributes dot login, and we get this value. So, and we can use it wherever we need inside the script. So the next one is OIM attributes. It's also a hash table that contains attributes that are related to some particular request, like we described here, like display name, member of, name, etc. So let's just type OIM attributes, and we will see this collection. So we have just seen a display name here, yeah, so we can just type OIM attributes display name, and we will get another hash table that contains the value and the operation. And if we take a look maybe on groups, yeah, like we discussed here, if we take groups, yeah, we will see that we have two values here. So you can go through all values and do what was requested. What about search attributes? So it contains just the list that was requested by OpenIAM from a connector side, and let's return to this global variable a bit later. Well, maybe not later, but let's return to this now. But before, let's go and change our file to search example JSON. Okay, so I will close this, and I will press Shift F5 to stop execution. And let's go here and make sure that we now reference. We don't need this. That we reference this file, and we are changing the operation to search. Okay, so if we take a look on this file, let's open it with Visual Studio Code. It contains the same attributes, but the values are null, but it contains just a list of attributes. It means that OpenIAM wants to know what's the value of the length, the display name, the path, the member of, the name, etc. inside a remote system. So, and it actually needs to find to find this information using a search query. So search query is the piece of data that is sent from OpenIAM site, and it contains some request that is used for searching information inside your remote system. So get remote data here is just a placeholder. You can specify any request you would like to. So let's go back. Let's go to search data, and it just contains a default implementation that takes some request data. If we see that we are addressing a search query like header attributes, then we go to attributes, then search query, and we take the value. So let's put a breakpoint here, and let's run it. We see that we received a request here, and yeah, so the search query is get remote data. So we can get back here, and we see that search query is located inside attributes. Yeah, you see attributes, and this attribute is located inside the header attributes, and from a search query we take the value. Yeah. Okay. So I think that we can maybe take a look on it in practice, and let's follow this document and take a look what we have next here. Yeah. So in this document we describe that we can define some function that that returns some data and takes, for example, one parameter. So okay, let's do similar thing. Let's for example create some function. Let's call it get remote info. Let's call it like this. It doesn't matter actually. What does it? Okay, so okay, in this example it takes one parameter. So let us copy it here. But for example, I have actually just a test file for a synchronization that just describes an array of some objects that contains some test data. So let's imagine that we have received this array of users or objects from some remote system, from SAP Active Directory or whatever remote system. So it's just array of objects. So let's instead of organization ID, let's maybe type a file name, and let's read this file name. Get content, and let's copy it as path and specify it here, and let's convert it from JSON. Content convert from JSON. So actually all this function will do is get this content and convert it from JSON, and it will actually write it to output stream and will return data to your calling site. So if we take a look on a search data, it executes a search query. So everything that we have specified in this location, and it will be sent from OpenIAM site actually. So it will be executed as a raw query. So let's take a look how we called it. We called it get remote info. So let's set it like get remote info, and we have specified a file name here. So let's put a parameter here minus file name, and let's copy it like here, like this. And I will put escape here. And how we call this file? testsync.txt. Okay. Yeah, so I have saved it, and we can put a breakpoint here, and let's execute it. Actually, yeah, let's put a couple of breakpoints. Yeah, so you see that we received this request and we get this parameter. Let's go to the next breakpoint, and we see that the remote result consists of like four objects. This is the result of that was taken from our test file. So actually it contains four objects, and each object has some properties like given name, surname, and so on. So what connector, the default connector implementation do here? So actually you don't need to change anything here. It just takes the list of these attributes like length, display name, path, member of name, and it compares it to the results that were received from some remote system using this raw query. So instead of this implementation, of course, you can implement some calls to remote API. And do whatever you need to get the data. So, and after that, you have received this object that contains the list of properties. So connector will just iterate through this object, and if it has some matching attribute like name, for example, and we remember that we have name here, so it means that this name will be returned back. So let's let it go, and we will see that the execution result is here. So it just made a formatting of this result to a format that is acceptable by OpenIAM. So you don't need to change this format, but you will see that, for example, the name, where we can see the name, the member of, we see that we have three values here. It's an array of values, so actually everything is array, like it's an array of values. So like given name, let's see where the name is. Yeah, the name is here. So we see that operation is always no change, just because it's required by a protocol, and the value is taken from our file, and in our case it's let's imagine that it was some remote system. So the next section is about working with logs. Yeah, so if you check a connector folder, you would see the LogDB file, which actually a SQL Server Compact Edition 4.0 database. So if we go to a connector folder and we'll take a look, so LogDB is located here. And as for me, I prefer to use a link pad just because it allows you to write not only SQL query, but queries that are that can be defined in link notation, like you do for your .NET .NET solutions. So if we take a look on connector itself, it contains some calling like write debug log, like walk-in save identity action, and so on. So we have write debug. Actually, if we open up connector shared, let's open it in Visual Studio Code and scroll down, we will see that actually all of those functions are defined here. So when you implement your custom functionality, you can just write debug logs, and all of them will appear inside this LogDB. So I will open a linkpad program. They have it connected, but let's just delay this connection so you can edit. Just press next, and you pick a SQL Server Compact Edition for the 0, and you go to your connector folder and remove filter to see all files, and select LogDB. Let's test connection. It is successful, and open it up. It actually contains a log table. And I make a reverse order by ID, and I'm able to see all logs. So when request is executed, actually it contains nulls here just because we were working in a simulation mode. But when connector works in a real mode, so connector main service, when receives a request, it gives your request a request ID, and using that request ID, it would be easier to track all of your uh, request logs. Because, for example, if you like even make a reverse order like this, um, the reason is it is a database, and connector can run in multi-threading, and so several different applications can concurrently write to this log table. So consequently, when you will be working with real request searching, you will probably need a request ID or identity value to distinguish what request are you looking for. Okay, so that's what we wanted to describe about writing logs. Okay, so the next section is developing a .NET modules. So yeah, sometimes it's PowerShell. PowerShell is very flexible, and it's very easy to start developing using PowerShell. However, sometimes it can be not very convenient in some cases, and in some cases PowerShell functionality is not enough, and it is better to write some implementation using .NET, using any language, .NET language, for example, C# or Visual Basic .NET. Because it's more powerful in general, and you have more abilities to implement. So it is easy to develop a .NET module, which is actually a .NET library, do some implementation, and load it as a module inside a PowerShell. So in our example, we do some we do some module creating and import it to a PowerShell. So let's do the same. I have Visual Studio 2022, and let's create just a class library. But please pay attention that, and it is described here, that we need to use a .NET framework, not a .NET Core. So we select a class library, making sure that it is a .NET framework, and let's call it I don't know, test PS. Let it be a test PS module, and let's make sure that it is targeted to .NET Framework 4.5. It's quite old. However, it will get us ability to work with all observable range of Windows operating system without need to do any installation or any dependencies, etc. So we use .NET Framework 4.5, and we just create a library. Okay, so we see that it's just a default library implementation. It has just this class. And actually, if we take a look on this document, so it's described right here that we need to create it to target 2.5.NET Framework. And the next thing that we need to do is to add a system management automation reference to our project. So let's go to references and add a reference. And if you browse, yeah, I already have it here, but if you press browse and if you go, it's usually located in C, program files, x86, then reference assemblies, Microsoft, PowerShell 3.0, and you have system management automation here. So you can just add it as a reference, and actually that's all references that you need for creating a PowerShell module. So I would like to say that it is possible to add this reference using NuGet, but if you use a NuGet, then the versions of system management automation is higher. So, and in our case, we are trying to create a solution that is compatible with all, even legacy, even obsolete versions of Windows. So that is why we created our solution based on .NET 4.5, and we referenced exactly that version of library system management automation. So actually, you can reference it using the path that I have shown to you, and also you can go to a generic connector folder, and I think that we can find it here. System, let's see, management, where it is. Management automation, here it is. Yeah, let's take properties, details. Yeah, okay. So what we need to do, let's go back to our document. We just need to make inheritance from PS commandlet. From PS commandlet, let's add reference. It's using. And the next, what we need to do is just to give the name for this commandlet. So let's, yeah, you see that Visual Studio offers this for us. So get, I don't know, let's give some name like let's call it just library data. So this tells us how our commandlet will be visible inside a PowerShell session. So we see that the verbs common is a constant, and it's just a string. So actually, PowerShell commandlet, they contain the verb and the noun. So in our case, the verbs are commonly known, and it's how you can use any verb, but it's a good practice when you use one of the common verbs. And I think that it is described in the document, and you have the link for approved verbs here. So in our case, we will be able to call this commandlet in our PowerShell session using get library data. Okay, so also let's imagine again that we take some parameter. Yeah, Visual Studio offers this help, and let's create public string. Let's call it again file name. So we will do actually the same, but we will just read the file content using this library. That's the difference. So yeah, probably just instead of what we did here, instead of getting just content using a PowerShell method, let's get the content of this file using our newly created library. So what we do here is we need to override process record. So if you take a look, there are different methods to override, like begin processing, end processing, stop processing. You can read about this, but the one that is enough to start with is a process record. It means that when you call this get library data, the real action will be executed in this method. So let's read the content of this file. I will not do any checks just for simplicity. File, and I need to put using system input output readall text file name, and so we will read the content of this file, and we need to do a write object. To be able to write this object to a standard output stream of PowerShell. So if you need to write some error, so you see write warning, error, and actually you can read about this, but let's do very simple default implementation, and that is it. So that's all. Let's compile this module. So we see that it is compiled, and let's go here, and actually, yeah, we have like import modules function in our connector here. So it does some importing modules. In our case, it imports a log modules and share connector module, the one that we have seen here. So it is a PowerShell module, and in our case, we will load our DLL library. But if you need just to do it once, maybe, and only for some operations, like for searching some data, so you can just implement this importing in some location that will not affect like other functions. So let's again imagine that we are using the same example. So we get remote info, then the file name, but instead of this call, let's do like import module, and let's put the name of our the path to our module. Let's write it like this, and let's again do it like, and use the name that we have given to this commandlet. So get library data. And we have one parameter here that is called the file name. So minus file name, and yeah, let's just use the same parameter that we will receive in this function here. Yeah, so actually what we will receive is this. Yeah, so that's actually all, and when we don't need this module anymore, we can remove module and specify the name. So if while importing module we specify the paths, but we while removing it we can specify the name. So that's all. Let's save it. Let's put a breakpoint here instead, and let's run. So we see that we imported this module, and we have successfully read the same information from this file that actually is implemented inside our .NET library. Now we remove this module, and that's all. So we can continue execution, and we get the same result. So yeah, here it is. Yeah, so actually this document describes exactly the same. Yeah, but just it describes a little bit in a different way, maybe uh, just showing the output. In our case, we implemented some search. So looks like we covered all the aspects that are described in this document. So if you have any questions, feel free to contact OpenIAM team. We will be happy to help you. Thank you for watching.